Hi, I'm Mark Nossokoff, Research Director and Lead Analyst for Storage and Interconnect and Cloud Research at Hyperion. Thank you for joining us today. In this portion of today's program, I'll be sharing our latest perspective on storage and interconnects for HPC and AI solutions. I'll start with a refresher we've shared before about the broad range of demands placed on storage solutions across the AI data pipeline. Each stage places unique and sometimes conflicting demands on the data and I/O requirements of the system. Storage solutions have evolved far beyond just performance, such as bandwidth, throughput, and latency and capacity, and into data platforms that increasingly know about the data and do more than just move it and store it. As you can see, each stage places different requirements across multiple dimensions on each stage of the pipeline. Access pattern, access type, access frequency and intensity, amount of data, and locality all have an impact on requirements at each stage. Other areas impacting requirements and performance of the data platform and system interconnect include model training, type, frequency, and size, data type, data mode, security, compliance, and last but not least, the parallel file system, and whether one is needed at all. So from that perspective, and with the AI data pipeline in mind, what's happened across the storage and interconnects ecosystem since SC24? Starting with storage and from the business side of things, Blackstone and DDN announced a significant relationship, with Blackstone investing $300 million in DDN. This is notable due to DDN's long-standing independence as one of the leading providers of HPC storage solutions. Moving on to vendor announcements, HPC and AI system vendors were active with storage and data platform solutions to complement their AI server offerings. Dell introduced its AI data platform aimed at agentic AI applications, announced enhancements to its ObjectScale product line focused on AI model training and large-scale data sets, and shared more insight into Project Lightning, its parallel file system for the PowerScale family. HPE focused its AI storage efforts more towards enterprise AI workloads with enhancements for its Elytra family of storage. Data platform vendors also made significant announcements. DDN launched the second generation of their Infinia platform software and announced a partnership with Google, supporting them with the Google Managed Lustre service based on Exascaler. Hammerspace advanced their data platform with support for Tier 0 storage, unifying stranded storage across multiple GPU servers, and along with Linux kernel announcements, aiming to alleviate the need for proprietary client software and to augment open standard PNFS file system support. VAST expanded its data store to include block storage, complementing its support for file and object data types. But probably more significantly, VAST announced its AI operating system, focused to natively unify and orchestrate storage, database, and compute, aimed largely at agentic AI-driven compute and data-intensive application needs. Weka announced its storage platform, uniquely powered by NVIDIA's Grace CPU, and also its augmented memory grid, aimed at memory wall challenges presented by AI inferencing workloads. There are several interesting items on the interconnects front as well. Co-packaged optics and switches with integrated silicon photonics were a key topic at NVIDIA's GTC, with indications there'll be production options in its next generation products. Also at GTC, much greater emphasis seemed to be placed on Ethernet than on InfiniBand. Progress is being reported along the interconnect standard front. Ultra Ethernet Consortium now boasts over 90 members, including those with alternative offerings, such as founding member Evidin with VXI, and contributing members Cornelis with Omnipath and NVIDIA with InfiniBand. Opponents are also actively making contributions to the Linux kernel. The Ultra Accelerator Link Consortium released version 1.0 of its specification, and Euro HPC Joint Undertakings Net for Exa project shared aims to deploy Evidin's BXI version 3 for exascale integration and intent to develop a roadmap for BXI version 4. Probably most notable, though, when considering interconnects, is NVIDIA's recent announcement of NVLink Fusion. It's an initiative to allow support and integration of third-party non-NVIDIA CPUs and GPUs into NVLink-based systems. With NVLink Fusion, NVIDIA has effectively opened up its closed NVLink ecosystem for others to design into. It's unclear yet what, if any, impact this will have on the Ultra Accelerator Link. NVIDIA's announcement of co-packaged optics and silicon photonics prompted us to review a study that we conducted a few years ago. In it, optical I/O was cited as the technology that has the highest potential to improve HPC architectures in the next 2 to 6 years. We're now in the front end of that 2 to 6 year prediction range, and the study may yet prove to be prescient. Where do we go from here? This may seem like a static, repetitive future research material. It largely is to a certain extent, but not because no work has been done. It's because as requirements and architectures evolve, most recently driven by advancements and innovations in AI, market sentiment towards each area shift, and steady-state impacts as a result of each area remain to be seen. Each area warrants continued study and research. Thanks again for joining us today, and we'll see you next week in Hamburg.